Alright, welcome back. We'll continue with chapter 14 on circular functions. With 14K, two main things we're going to look at. First one is complementary relationships. Complementary means when you have two angles that add up to 90 degrees or pi on 2. And the second part will be the using the Pythagoras theorem is coming up with an identity linking circular functions and solving some application situations. The first part with complementary angle, let me get my laser up, is usually we have our unit circle. So we in the first quadrant, we have point P that makes an angle theta with the x-axis. Its coordinates are on the side. Remember, it's a unit circle, so the hypotenuse is 1. The coordinates are A and B for a right angle triangle, which in terms of theta will be cos theta and sine theta. If we take that triangle and we flip it, move it to that side, so that A side will be over there and the B side will be flipped that way, we end up with a new point that makes a different angle to the x-axis, which is, if you go all the way to pi on 2 and go back to theta, it's going to be pi on 2 minus theta. Now its coordinates now would be B and A respectively. B has been calculated from on that side, and A, this side, is the same as that vertical one. So if I use, let me see if I can use colors. So cos theta, let's say in orange. So cos theta is here, which is the same as this side. But that side, in terms of that angle, it's sine of pi on 2 minus theta. And we end up with this relationship. So cos theta this side, that's cos theta, is equal to sine of pi on 2 minus theta. And with, so for P of theta, that side is sine of theta, and for this side it's in terms of pi on 2 minus theta, which is cos or pi on 2 minus theta. Those relationships you need to know. So a quick way to remember, it's minus theta from pi on 2, and what you do is you cross the sine is equal to cos, and the cos is equal to sine. Another, it's kind of a derivative relationship. Instead of moving and flipping the angle to be complementary, what we do is this time, with the same triangle, we do a rotation of 90 degrees. So by moving a rotation of 90 degrees, you can see you end up with this point here, and the angle is pi on 2 plus the angle of the triangle, which give us pi on 2 plus theta. Now its coordinate will be cos of pi on 2 and sine of pi on 2. So this side is cos of pi on 2 plus theta, and the vertical one is sine of pi on 2 plus theta. But we're going to relate that to A and B. So it's the same triangle, they're congruent triangles, so A and B are the same, but for this triangle, A and B are equal to cos of theta and sine of theta, and we can generate those new relationships. So sine is equal to cos of theta, and cos of pi on 2 plus theta, which is the horizontal one, but it's negative, so it's negative sine of theta. So another set of relationship that you need to know and you need to apply in some sort of problems that relate to circular functions. All right, the last one is, remember in the unit circle the radius is equal to 1. When you place your point P of an angle theta, you have a right angle triangle, and if you use the Pythagoras theorem, you have a squared plus b squared equals c squared, which is your hypotenuse. But this time we substitute a by cos, b by sine, and c is equal to 1. We end up with this relationship: cos squared plus sine squared of the same angle is equal to 1. That will be valid in any quadrant, and we're going to look at the first example, which you need to pay attention to the domain of the angle that you trying to determine. So here I'm going to use a pen. Look at that question. Sine of x is equal to 3 over 5, and what you have is the angle value x, or the angle, which is your theta. Sometimes they change the variable, is between pi and 2 and pi. So between pi and 2 and pi, I always like to have my unit circle. Pi and 2 and pi is the second quadrant. And if you remember your acronym, all students to Craigie-Burn, in that quadrant only sine is positive. So what it means is cos and tangent must be negative. Okay, so do keep that in mind. If you get the wrong sign for the answer, then you lost all your marks. So how do you determine cos? Is you're going to use the Pythagorean's identity. So with the Pythagorean's identity, what you do, alright, so using the Pythagorean identity, you substitute sine of x with 3 over 5, you square it, you make cos square the subject, and you get cos squared is that amount. They are perfect squares. So what you can do now is square root, and you're gonna end up with two answers, a positive and a negative. So as I mentioned before, cos of x is negative, so it's gonna be cos of x is negative 4 over 5, and that's the only possible solution. To find tangent, you use the definition of sine over cos. We determine our cos from previously. We do the ratio, and we end up again with a negative answer, which is what we need to get in the second quadrant. And that's it for 14K, and I'll see you in the next video.